Welcome to Chapter 5, Subnetting. Subnetting is a method used to divide a single large network, specifically a set of a large IP address, into two or more smaller subnetworks, or two or more set of smaller IP addresses. There are many methods of doing subnetting. However, I believe that my method will be much easier for you to learn how to do subnetting. So let's begin. Assuming that we are given an IP address of 192.168.1.50/28. The /28 is called the prefix, or simply the CIDR notation. Now, given this IP address right here, we need to find the network ID of this subnet. We need to find the number of hosts available for this subnet and other subnet. We want to find the number of subnet for the IP address here, and we want to list all of the subnet and its network ID, first host ID, last host ID, and broadcast ID. So the first step, number one, is to write down the CIDR notation into a binary number and convert it to a decimal value, where it will become your subnet mask. So /28, we simply write down 28 of the number 1, which is bit 1. Okay. Now, this is the first octet. It has 8-1. Second octet has 8-1. Add them up, that's 16. Another 8 1 bit, make it 24. And 25, 26, 27, 28. That's where the 28 coming from. They're simply 28-1. Then we simply fill the rest with 0. Okay. Now, for this particular subnet, the first 3 octets right here is known as the network portion, and the last octet is the host portion. Now, we need to convert this number into a decimal value. So I already converted the first 3 octets, which is nothing more than 255, 255, and 255. Now I need to convert the last octet binary number into a decimal. So let me copy this, and let's call up our calculator. And I want to make sure that I'm using the programmer calculator. Okay. Alright. Now I want to convert the last octet 1111.000 into a decimal. So I click on the binary, and since I already copied, I'm just going to paste it. There you go. And it automatically converted to decimal right here for me. The decimal value is 240. So this is going to be my subnet mask for this set of IP address right here. Okay. The next step is to convert the IP address into a binary number. I already did the first 3 octets already. Now we need to convert the 50 into a binary. So I'm just going to copy this right here, and I'm going to call it my calculator, and I'm already using the decimal format or decimal mode, so I simply type 50. Notice that it automatically converted to binary, so I click on this right here, and notice that there are only 6-digit display, so we have to add a 00 in front of this 11. As a matter of fact, it is showing right here for us 0011 0010. Okay. So the binary value for 50 is 00110010. Then the third step is simply apply the AND logic function to the two binary number that I just converted. Okay, now when I apply the AND logic function, it is 1 1, then it's 1 1 1 is 1 1 0 is 0 1 0 is 0 1 0 0. So 1 1 1 1 0 0 1 1 1. Now I hope you see the patterns right here. And 0 1 is 0. So the AND logic function looks pretty much like a multiplication table. Now once I get my result, I simply convert that binary number to decimal number, and it is 192.168.1.48, which is the network ID of this IP address right here. So now we have found our network ID, okay, for this subnet. Now the next step, we want to find the number of subnet and the available hosts. To do that, that's step number 4. We use the binary cider notation to determine the number of subnet and also the available hosts for each subnet. Alright, so we write down the binary number of the /28, and notice that I put a line to separate the borrow bit and the host. So these 4 bits right here, 1 1 1 1, are the borrow bit because we borrow the host, okay, and the number of borrow bit is equal to 4, and the number of hosts is also equal to 4. So the formula to determine the subnet is 2 to the n. In this case, n is 4, so 2 to the 4 is 2 times 2 times 2 times 2 equal to 16. So the number of subnet for our set of IP address is 16. Next thing, we need to find the number of hosts. The formula for the number of hosts is 2 to the h minus 2. Okay, 2 to the h minus 2. Alright, let me do this right. 2 to the h, there you go. Again, the formula to find the number of hosts is 2 to the h minus 2. Well, why is 2? 2 is one of the IP address is reserved for the broadcast ID, and the other IP address is reserved for the network ID. That's the reason why we minus 2. So the h is equal to 4, simply 2 to the 4 minus 2, which is equal to 14. So the number of available hosts in each subnet is 14. Now the next step, we need to find the magic number or the place value. The magic number is the first bit on the right of the borrow bit. So it is this right here. Well, let's look at it. This is bit number 1. The place value is 1. Bit number 2, place value is 2. Bit number 3, place value is 4. Bit number 4, place value is 8. And this bit right here happen to be 16. So the place value or the matching number is 16. Now we can write our table or fill in our table. So the subnet mask for this set of IP address is 255.255.255.240, and the number of network or number of subnet is 16. That's total of 16 subnet. And the number of hosts available for each subnet is 14. Alright, our next step is to write down or list all of the available subnet. So the first subnet always begin with 0. So the network ID for the first subnet is 192.168.1.0. Now, how do we find the next block? Well, notice that the magic number is 16. Let me take these off so we can work on them and show you. Alright, so the magic number is 16. What does that mean? Well, meaning that there are a total of 16 blocks in each subnet. So to move to the next subnet, we need to add 16 to it. So the first subnet is .0, or the first network ID is .0. So we want to add 16 to 0. It's simply 16. This is the second subnet, and the network ID is .16. To get to the next, we simply add 16 to that 16, make it 32. Add 16 to 32, make it 48. And add 16 to 48, make 62. And 62 added to 16 and make it 80. And we keep on adding all the way to 240. Well, if I add 16 to 240, it will be 256. 256 is bigger than the maximum allowed in networks. The maximum, or the highest number allowed in network, is 255. So 256 is not a valid subnet. Okay, so our last subnet is 240. Alright, let's see. Is that total 16 subnet? Sure is. There you go. Number of subnet, 16. So it is 16 subnet. Now what we need to do, we need to determine, or we need to find the first host IP address. Well, the first host IP address simply one number bigger than the network ID. So that's 1. Now the last host IP address might be difficult to find, but we can find the broadcast ID, okay, or the broadcast IP address. The broadcast ID is nothing more than one number lesser than the next network ID. So one number lesser than the 16 is 15. Now the last host IP address is simply one number smaller than the broadcast ID. In this case will be what? 14. Okay. Now let's find the first host IP address for this network ID. Well, the network ID is 16, so the first available host IP address is 17. Now what is the broadcast IP address? Well, the broadcast IP address is one number smaller than the next network ID, which is, in this case, 32 is the network ID, so one number less than that is 31. And the last host IP address is one number less than the broadcast ID, or the broadcast IP address. Okay. Now by now you should know how to fill the rest. So the broadcast IP, or the broadcast ID, is what in here? Is 47, because the next network ID is 48. So in this case, the last host IP address is 46, and the first host IP address is 33. And we keep on going until we get to the last subnet, or the last network ID, which is .240. So the broadcast IP address of the last subnet is 255. Okay, so that is 255. So the last host IP address of this network ID, or this subnet, is 254. Well, what do we mean by this? We are meaning that this setup subnet, or this network ID, will use the IP address of 192.168.1.1 all the way through .1.14. Okay, so the IP address available that we can assign to an end device such as PC, server, printer, stuff like that. All of those are the available host IP address. So we can use any number between these right here to assign to our host. Okay, host meaning the end device, right? Alright, such as printer, server, or PC. Now for this particular subnet, we can use the IP address of 192.168.1.17 all the way to .130 to assign to a host or end device. So there are a total of 16 subnet. Okay? Alright. Question. What is the place value or the magic number? Well, we already find it. It's right here, 16. Now next question. What network ID the above IP address, that is this IP address right here, belong to? Well, let's look. 192.168.1.50, where it fell into. Well, it falls into this range right here. Okay, it falls into this range because this is .1.49. so the next one will be .1.50, which is right here. So it belongs to the network ID 192.168.1.48, which is this right here. Okay, now can this IP address be assigned to a host? In other words, is this a valid host ID or an IP address that we can assign to a PC, a router, a printer, or a server? And the answer is yes, because it is within this range. Okay, so the answer is yes, because the IP address of 192.168.1.50 is in the subnet of 192.168.1.48. Okay, alright, we will continue in the next video.